Alrighty, so here we go. If you watched the last video, you saw that the way that we are going to generally prove that parallelograms, or that a quadrilateral is a parallelogram, is by saying that one pair of opposite sides is parallel and congruent. Okay, one pair of opposite sides is parallel and congruent, so we want to prove for example, over here, that this side is congruent to this side, and it's also parallel. Okay? So, over here, I have a proof. The first given is that ABCD is a quadrilateral. Just like always, if you have no idea where to start, you start with your first given, and you get that down. You're getting at least 1 point for that. Okay? There's nothing we can really do with that. All it's saying is that we have a four-sided shape. And that's just to clarify that you're not working with a triangle. A triangle can't be a parallelogram. A quadrilateral can be a parallelogram. And a parallelogram has to be a quadrilateral. So that's why we have to state that. Okay? So we can check that off. Boom. Next is our next given. Now, you may be looking at this and thinking, Mr. Briggs, I thought we couldn't assume that opposite sides are congruent because we don't know that it's a parallelogram. And I agree with you, okay? So this given says that CD is congruent to AB. And if we're looking at this diagram, CD is here, AB is here, and they're congruent, okay? And that does mean that opposite sides are congruent. But here's the thing. We are trying to prove that it's a parallelogram. So we do need to try to prove that one pair of opposite sides is congruent and parallel. We've done that first step. We've said, okay, this is congruent to this. All that's left to do is prove that they're also parallel. Okay? So this is going to be a freebie. There's nothing we can do with it. There's no theorem that goes along with it. We're just going to use that at the end to say we have an opposite side, parallel, and congruent. So step 3 will be our next given, which is angle HJA is congruent to angle FEC. So I'm going to come down here, I'm going to change my color to make it easier for myself, and HJA. So HJA. So that's talking about this angle right here. And let's see, FEC. That's talking about this angle right here. Okay? So, should be looking at that, and as soon as you draw that, you should see this Z shape. Okay? See the Z shape, and you know that it's going to be alternate interior angles. Alternate interior angles, big thing of this whole unit. Okay? So, our theorem that's going to go along with this, it's kind of the opposite way around, because before we would say, okay, we have opposite sides parallel, therefore the alternate interior angles are congruent. Now we're going to say, since the alternate interior angles are congruent, we must have parallel lines. Okay, so our theorem, and we're going to be adding this to the theorem sheet. The theorem is that, and we'll get the wording a bit better here. Congruent alternate interior angles create parallel lines. And that's why we had to state that we had parallel lines in order to say congruent alternate interior angles. They work hand in hand. So now we are saying that we have parallel lines somewhere. And our parallel lines are the two that make up our alternate interior angles. So DC, or CD, is going to be parallel to AB. And I'm sorry I didn't put the segment symbols above that. But now we know that this is parallel to this. Cool. So up to this point, you should not necessarily know what to do, but you kind of have an idea. You should be familiar with freebies, and you should be familiar with alternate interior angles. So we've gotten a pair of sides that are opposite each other, congruent and parallel. So our theorem now is going to be a quadrilateral with a pair of opposite sides. We'll go this way. Parallel and congruent is a parallelogram. Okay. So I'm going to enter, space it over. There we go. So our conclusion is that ABCD is a parallelogram. Okay? That's it. They will get more difficult. I was trying to put in a smiley face, but it wouldn't let me. They will get more difficult. Generally, they'll have to prove triangles congruent first. But the goal is one pair of sides, congruent, parallel. You're generally going to prove the parallel part using alternate interior angles, so get used to that. And we're going to see what a more typical one looks like in the next video.